All right, we are in the fourth video now of chapter 10. We've been looking at redox reactions. In this one, we're going to look at batteries, which are pretty much redox reactions in a can. So we're going to be looking at those. Here is an example that we should be being able to look through, and let's just kind of identify what's going on. In order to have a battery, you have to have a circuit. You have to have a complete circuit, which means the electrons have to be able to flow throughout. This is accomplished, okay? This is kind of not really looking like a normal battery to you probably, but we're going to look at this reaction first, and then we'll look at what it looks like actually in a battery. So there's a couple things going on. You need to have some electrodes. In this case, these are going to be metal electrodes. You can see on the left there is a zinc electrode, so just a zinc piece of metal. And then on the other side there's copper. And then the zinc one is in a zinc solution. And then the copper electrode is in a copper solution. Now these are with something else. So these are the cations, the zinc and the copper. There's probably some nitrate or some anion there that's not very reactive here. And so then you have this wire that can then go from the copper and the zinc, attach those two electrodes together so that electrons can flow. And then we also have, you can see kind of this weird setup at the bottom. You can see it's labeled salt bridge, and it has some Na2SO4, so some sodium sulfate solution kind of right there. And that sodium sulfate is able to go in either directions. And you'll see that that salt bridge is necessary to keep the charges kind of equal together. Let's look at when we hook this up, okay, when we attach those two electrodes together, what happens to make this a battery? In order to have a battery, we have to have a flow of electrons. Where are the electrons coming from, and where are they going? So let's look at this reaction in a little bit more detail. All right, so let's see what is going on here. And it already is a little bit labeled for us. We're going to get an example later on where we're going to have to do the labeling and figure out where the electrons go. Look at these images close up. Okay, so here is this zinc metal, and here is some zinc ions. Now, what is going on here? The zinc is going to start giving up electrons. So it's going to get oxidized. Remember, oxidation is the loss of electrons. So we're going to start with the solid zinc, and as it does it, it's going to lose electrons, and the electrons will go from the wire from the zinc electrode to the other wire. So they'll flow this way. You can see the kind of electrons going around here, going over here. And as it does that, when zinc loses the electrons, okay, it forms zinc plus 2, okay, the zinc ion. Now this is going to go into solution. So this is a solid, and this is now aqueous. And so you can see as the electrons, so here's a zinc atom on that metal electrode, as it loses electrons this way, it also produces zinc plus 2 ions. So it already has some zinc ions in solution, and we're adding more to it. So the overall charge on this side of this battery is getting more and more positive as we're losing electrons this way. All right, we'll come back to that. Now let's look and see what's happening on the other side of this battery. We can see that the solution is a blue color. We've already talked about that. Plus 2 of the copper is slightly blue. All right, so this is plus 2 copper solutions. All right, we have the copper electrode as well. As electrons come in, they're going to join up with a copper ion in solution. All right, so here's a floating around copper ion. It's going to join up with these incoming electrons, and now we have formed another copper atom, and it's attaching just on that copper electrode. So this is the reduction reaction, and it's showing that here we had some copper ions in solution. We have electrons coming in from that wire, and they join up and they make solid copper. Now let's look at what's happening in the solution here. You had a bunch of plus 2 ions, okay, and some nitrate or whatever else was in here, sulfate, nitrate. And as this reaction's taking place, okay, the copper plus 2 keeps getting reduced, meaning it's gaining electrons, and it's forming solid copper. And so now the copper that was in solution is leaving solution. So instead of being kind of even positive, negative charge, we've been losing positive charged ions. That's why this salt bridge is important. Okay, the salt bridge, this is Na plus ions, and SO4 2 minus ions. Like we said, this solution over here keeps getting positive. So this solution, as this reaction is taking place, as oxidation is taking place, becomes more positive as we keep making zinc plus 2 ions. To counterbalance that, some of the sulfate is going to move across the salt bridge into this solution over here. Now, on the other side, on the copper electrode side, we have the copper ions that were in solution, kind of balancing it out, okay, keeping it neutral. They are now forming copper atoms. So now we're losing positive charge. This solution becomes more negative. So to balance that, the sodium from the salt bridge goes into this solution. So Na plus balances the charge. And over here, it was the SO4 2 minus balances the charge. Now that's important. If you're trying to move electrons over, okay, and we want electrons to flow from the zinc electrode to the copper electrode, you want to make sure that you don't have a negative solution, okay? If this solution is already negative and you're trying to have more negative electrons come, they're not going to want to come. Electrons, negative charges will repel. So we have to have that salt bridge. Is very important to complete the circuit and also to move the ions around. One other thing I want you to know about this battery is as these two reactions take place, the zinc is getting oxidized, it is losing electrons. The copper is gaining the electrons, it's getting reduced. They have to happen at the same time, okay, for those electrons to get moved around. But let's also look at what's happening overall. The zinc electrode keeps losing the zinc atoms. They keep breaking apart into electrons and going into solution. So the mass of this electrode, the Zn electrode mass, so solid, as the reaction goes, will decrease in mass. So as the reaction goes, a lot of that zinc on there is going into solution and you're losing that electrode. So this battery will stop when we run out of solid zinc. And guess what is happening to the copper? As the copper ions in solution there join up with the electrons that are coming on that wire, you're making copper atoms. So this electrode, this copper electrode, the mass of it is increasing. So now I think you have a little bit of an idea. Oxidation, reduction taking place. These are called half reaction. So here's what's happening in the oxidation side. Zinc is losing electrons. Okay, so oxidation is the loss. Here is the half reaction for the reduction. And that's showing the gain of electrons. So copper ions in solution now are gaining electrons and forming solid copper. All right, so I think that will lead, let's see what we have on this next slide. We are now going to just kind of show what's going on in an actual battery. All right, so this looks like a standard cell battery. We will call this redox in a can. All right, reactants here, we have magnesium 4 oxide and zinc, and the same thing is going on here. Okay, you can see that they're separated from each other. There's like a little bit of a pasty thing in between. That semi-moist paste there is ammonium chloride in this case, and that's acting as a salt bridge. You need that present as well. And you can see in this one, you have zinc solid. On the other side, you have +2 zinc. So oxidation number goes from a 0 to a +2, showing that it has lost electrons. It's getting oxidized. And then the oxygen's not changing here, but the manganese in the manganese 4 oxide goes from a +4 to a +3. So the manganese being reduced gains electron. Just a couple other terminology things. Okay, you have to have a wire. Okay, so when you are putting this in, you see that there's some terminals there. You have an anode and a cathode. The cathode is the positive electrode, and the anode is the negative electrode. Okay, and electrons will move from the negative end, okay, which in our case was the zinc, to the cathode, the positive end. All right, so that's showing a battery. There's also renewable or rechargeable batteries. There we go. We have a lithium rechargeable battery here just to kind of show you the example here. This has some cobalt +4 in it on the cathode, and you have lithium ions in a graphite carbon anode. Not that I need you to know too much, but you should just understand still that as this goes on, you are still showing electrons being gained and lost across. And then this is just renewable, and you can recharge it and you can go back and then do it again and again. So in this case, let's see, it looks like the lithium ions are giving up electrons, and then the cobalt is going from a +4 to a +3 and getting reduced there. So maybe you can get more and play and do some labs with batteries. We'll see how that all goes. And that will lead us to the end of this one. We'll have one more video on redox.